with a focus on how open and standardized technologies can help making smart farming technologies more accessible. Yeah, who am I? I'm Doron Gackstetter. I'm working at the Central Institute for Agricultural Sciences of TU Munich. And yeah, so let's dive right into the topic. So basically, we all have a certain understanding of what is meant by digital agriculture. So just as a short wrap up, the idea is take and use new advanced technology, ideally integrate into one system to make the production chain better, more efficient for the farmer side, from farmer side, and also stakeholder side. So basically, yeah, we all have a certain idea what's included there. So maybe sensors in the field, on a plant, on a crop. This might be different types of robots like drones or maybe autonomous tractors. Yeah, or advanced imaging technologies connected to this or satellites. So there's a bunch of different other things. Let's look at the farmer now. So farmers all around the world, they're put under pressure for different reasons. Some maybe also the same reasons, like for instance, global issues like climate change or biodiversity. These are global phenomena putting a lot of pressure on farmers' production. But also, like in Germany, we have certain public acceptance issues which put farmers and their production a lot under pressure. I think we are all aware of what digital technologies can do. Specifically, the potential in agriculture is, of course, making production more efficient regarding also resource demands, making it more transparent, of course, when we have more information and data. But at the same time, it could make reduce physical stress for the labor or may enhance animal well-being. So these are just some advantages. When we talk about potential, of course, we also need to talk about risk and challenges of adopting these technologies and why not every farmer in the world hasn't adopted them so far. So here I'd like to mention some major barriers, of course. Yeah, investment cost is a main issue here. We talk about fears related to maybe governmental control possibilities. We also talk about fears related to IT security threats, but also related to higher complexity of the system. So maybe 30 years ago, a farmer could still understand how his technology worked and also could do some improvements himself, but through the higher complexity of system, a certain dependency increase can be seen now. Basically, I want to focus here within this presentation on the last two aspects. So this is a lack of system openness and interoperability, which could be a fear, and also the loss of data sovereignty. And one keyword connected to this phenomenon is the vendor lock-in. So here we talk about a manufacturer which tries to lock a farmer into their system and policies by different instruments. So this can be on contractual level, so using licenses and connected upgrades and service fees, which might maybe run for several years and kind of locking a farmer into this product. And also can be technical, and this is more also the focus of this presentation. So we talk about closed systems where a vendor system doesn't allow to communicate across these borders with other manufacturers' products. And of course, the consequence is clear. The dependence on single vendors is by that a lot enhanced, leading potentially to higher costs, because a farmer can no more choose freely between products in the market which might suit better to him. And at the same time, this decreases his position in data sovereignty, meaning that he could maybe provides his entire data and just receives some information back and doesn't maybe know what happens with all the other data that he's providing. So far the background, the problem situation, and I want to present why, of course, open and standardized technologies can be a powerful alternative and means to alleviate vendor lock-ins. We are all in this community aware of open standardized technologies mean? So we'll keep this short. Yeah, so basically elementary components can be viewed, changed, and used publicly without any license. The interfaces support interoperability between systems, and they are often also available free of charge. Yeah, main advantages are also quite straightforward. It's like increasing the independence of the farmers from single providers, because they're not owned, these technologies, by only one provider, but by no one. There we don't have corresponding license costs to that, and also we can the products can be more customized individually and more collaborative to the system that the farmer needs. So basically, within the large scope of technologies, of smart farming technologies, I'd like to put to narrow this down to one area, which are sensor networks and IoT. I think we all have a certain understanding of what we're talking about here. So common computer networks of sensor nodes that communicate often via radio transmission. And this is actually a subsystem of IoT, which is more like the common communication network across all types of interconnected physical devices. So in this domain, we saw the last years a strong and dynamically growing variety and progress of technologies, and I want to present two of them as an example. So first of all, radio transmission technologies. Here we have a bunch of different technologies, depending also on the area of application. So when we talk, for instance, about personal area networks, we have like Bluetooth, RFID, and so on. And these are mostly on unlicensed frequencies, whereas we also have licensed frequencies on cellular communication, which are subject to costs for the user. But overall, these are all standardized, so this is not the issue here. However, the question of licensing and also making dependent on a supplier or not. So when you go further, data processing and transmission protocol is the next crucial technologies in sensor and IoT. Here we also see a large variety of different platforms in general for IoT, but specifically also for smart farming. And the question is always again, how can we establish interoperability between the platforms? And so here again, open and standardized technologies are an answer to many questions. What I'd like to show now in the following is the proof of concept of a sensor data infrastructure at our campus of the Thun School of Life Science at Weinstefan, which is uniquely based on open, standardized, and free technologies. So why did we do this? Why did we build up? Why are we about? And to build up this infrastructure is the following problem situation. We all know efficient data management is today the key to every top-level operation, and in our case, to research. But in agriculture, we have certain challenges related to continuous and automated sensor data acquisition. Like we have large ranges, about several kilometers, energy restrictions, there is no electricity outside in the field, maybe costs related to data transmission, depending on maybe it's licensed or unlicensed technologies, and also data security. The consequences that we could discover is that we have, of course, researchers which want to use sensor data for their research, but they are more like the appliers kind of this technology. They want to use it for their, let's say horticultural research or so. So basically, IT expertise is not their main business, and at the same time, we could see some kind of inefficient partial solutions, which took a lot of unnecessary expenditure of resources, and which kind of were barriers to developing the actual research idea. So what is our solution that we approached? It's basically we We develop an end-to-end infrastructure from the sensor node to the application, covering gateway, network server, and the entire data management. So the comprehensive provision of data processing services based on open pre-standardized technologies, with LoRaWAN as a network communication technology. So, as I mentioned, for data rated transmission and network communication, we use the LPWAN standard LoRaWAN, with the Things network as an implementation of this technology, of this standard, which is also freely available, can be used in community version, but can also be hosted. Everyone can host it him or herself. And yeah, for the data management, we're using the SensorThings API and the corresponding implementation of this, namely the Frost server, the Fraunhofer open source SensorThings API server, to manage, to organize, share the data. And basically, on top of all this, we put a graphical user-based management app for the sensors. So basically, that a user don't need to use a computer. They can use a command line interface, but we have a lot of researchers which are more comfortable with using a graphical user interface, and this is also part of this infrastructure. Basically, the question always is, how can we secure data? How can we manage user and access? And for that, we're also using proper standards like the OAuth 2 and software that implements these standards, like Keycloak and Shibboleth. For Shibboleth, thanks to Shibboleth, we can also use single sign-on for this infrastructure. So user only need one type of credentials and does not need to log in at every single application that might be used. Yeah, so what's the current state? So basically what we did so far is the gateways are installed. So we have a certain coverage already in Freising where we are outside, but it even goes to Munich. We have first smart farming sensor applications integrated. So moreover, this is a view on our graphical user interface inspired to the Frost server manager. So here we can already manage our Frost server and corresponding data streams. And one of our final steps is, and it was to implement Keycloak and finally to protect the data, the Frost server properly. Because if this step wouldn't be weren't implemented, of course, a user would not like to use it if it's sensitive data. So basically, this is our infrastructure that we have already at a certain production level. It's still in progress. However, there is already quite a good state, and we are now about to bring it to the people and into the research here at the campus. So yeah, what I'd like to conclude with this presentation is that a vendor login is a certain threat, of course, for smart farmers. It is a certain fear they have. However, what is similar development at the same time is that data security awareness is increasing, and also the awareness that interoperability of system is necessary, not only among IT experts, but also among farmers. Yeah, of course, open, standardized, and free technologies are a rising area of technologies which fosters and which supports user sovereignty and puts pressure on the current product designs of maybe before dominating market players. And what we demonstrated with our infrastructure is that actually every farmer can build up a sensor data solution already today with the available technologies. They're all free. Everyone can do this. Of course, it requires a certain level of expertise, and the maturity is still not at a level, and the public awareness that the many is convinced by that. This might in future change when farming profession becomes more digitalized. And together with, let's say, a reduced level of fears due to, let's say, open and standardized technologies and this do-it-yourself possibility, and overall barriers are lowered for farmers to actually access these technologies and to use them for their everyday business.
Thank you very much, David, for your presentation.